Good day everyone, I am Generous Bilipao, and now I will be showing to you my part, which is the understanding hidden assumptions about how statistical testing works. First is hypothesis testing. It is an act in statistics whereby an analyst tests an assumption regarding a population parameter. It is also used to assess the plausibility of a hypothesis by using sample data. As researchers, we thought that hypothesis based on previous research and logical reasoning is what is tested statistically. You are wrong. It turns out that a statistical test will not test the logical, intuitively understandable hypothesis that you see in the paper, but instead, it will test a null hypothesis, which is rarely one the researcher believes is true. In conducting null hypothesis testing, researchers will set up a null hypothesis, which means that there is no difference between groups or that there is no relationship between variables. This may seem strange to set up a hypothesis that we may not really believe, but the idea, according to Howell, 2002, is that we can never prove something to be true, but we can prove something to be false. There are two hypotheses to be tested, null and alternative or logical hypothesis. Null hypothesis is what we think is false, but not just because we have proved the hypothesis is false does not mean that we have proved the opposite or the logical hypothesis is true. As researchers, we must always remember to use words wisely when making claims saying a study has proved a point, because remember, we can't prove something to be true. Instead, say that a study supports a certain hypothesis or provides more evidence that the idea is plausible. These are just a few information about hypothesis testing, for this will be explained more in Chapter 4. Now, let us move on to the application activity, creating null hypothesis. Look at the research questions given below and create a null hypothesis. Among these three cases, let's focus on the second one. Number 2. Proctor, August, Carlo, and Snow, 2006. What kind of relationship exists among an oral language measure and a reading comprehension measure in English for 4th grade bilinguals? In this case, we can say that the null hypothesis is that there is no relationship among an oral language measure and a comprehension measure in English for 4th grade bilinguals, because this is what only lies in the head of the researchers thinking it is a false hypothesis. Now, let's proceed to the next question, which is who gets tested? So we will now be talking about populations versus samples and inferential statistics. As researchers, we are already familiar with these terms, for this is where we choose our respondents. To easily understand the relationship of these terms, let us focus on the image. Now let's talk about population. Population is a group of people in which you are interested. Then, from that, a researcher must test a certain selection of people called a sample. Inferential and descriptive statistics are two contrasting ideas. Inferential statistics are those that can be used to make inferences to the population that the sample is assumed to come from, while descriptive statistics are measures that are derived from the sample. Descriptive statistics may include counts of how many times some feature is found in a piece of writing, or graphs, such as histograms, which graphically show such counts. So those are the relationships and distinction of each term. Next is, what does a p-value mean? P-value is the probability of obtaining results at least as extreme as the observed results of a statistical hypothesis test, assuming that the null hypothesis is correct. Also, These are usually found using p-value tables or spreadsheets or statistical software. So p-value contains mathematical symbols. In the results section, this includes equations on how the p-value came up. But for those who are not fond of mathematical symbols, we can just skip to the later or discussion part. But remember that not all the information in the discussion part is complete because it also depends on how the author interprets the mathematical symbols and equations. Here, we will also be introduced in the terms standard deviations and degrees of freedom. Think of standard deviation as measuring how much people vary from the mean. The degrees of freedom basically counts how many free components you have in 46 statistical ideas, your dataset. Another hidden assumption of researchers is thinking that the only thing you need to glean from the results section is the p-value, which is wrong. To sum it up, the p-value is the probability that we would find a statistic as large as the one we found in the null hypothesis were true. In other words, the p-value represents the probability of the data given the hypothesis. This will be explained more in Chapter 4, so let's not be confused, for we will be enlightened in the next chapters. Now we are down to understanding statistical reporting. So this provides detailed performance information about any statistical result. There are many examples given in the module, so you can freely browse there to better understand this. But now we will focus on example number 1. So here are the questions we will have to answer. First, what does the R reported here refer to? The answer is that statistic R is used to give the results for a correlation. Second, this report does not give the degrees of freedom. Why not? The answer is the total number of participants is given instead of the degrees of freedom, or the n is equals to 61. Correlations don't report degrees of freedom. They report total sample size. Third question, what does the p is equals to 0.57 mean? P is equals to 0.57 means the probability of finding an R, or the result, this large or larger if the null hypothesis were true, is 57%. The last question is, the second reported correlation has a p-value less than 0.05, making it a statistical correlation. What do you notice about the relative sizes of the R values of the non-statistical versus the statistical results? So, the R of the first correlation is negative, but this doesn't make any difference. However, the second R value is 0.27, which is much greater than the first R value of 0.07. So let us remember that the larger a statistic is, the more likely it will have a small p-value. That is all for my part. Again, this is Generals Bilipao. Thank you and God bless.